Jupiter, the gas giant of our solar system. How were you made? What created you, and how did you come into existence? Let's try to figure this out. Welcome to What the Math. In today's video, we're going to be trying to recreate a gas giant from scratch. Not just Jupiter, but hopefully more than one. We're going to try to basically assume that this is the beginning of the solar system, and the proto-sun has just started to emit solar energy, and the gas giants started to form. We're going to start from scratch, so I'm going to erase all of this and create a completely new system. And here what we're going to do is, let's just see what it looked like in the beginning. Now we're going to start by putting a sun in the middle, but it's not really a star yet. This is still a gas giant-like object that is essentially a very massive collection of various material, specifically helium and hydrogen. Now around this object we're going to add a few rings just to simulate the actual accretion disk. So under the ring setting here, I'm going to choose Taurus, and everything else will be set to default, and we're going to add first ring. Let's actually add a few of them, and then we're going to expand this a little bit further into the solar system. Alright, so it kind of possibly looked something like this, except it was much larger than this. So this is like a smaller copy of what was there in the beginning. So this is our sun before it became a star, and it had a bunch of material orbiting around it. So this is also when a lot of the terrestrial planets started to form, like I showed you in the previous video, which you can find right here. A lot of the dwarf planets started to kind of collide and create these protoplanets, and some of them have basically created Earth, Mars, Venus, and Mercury, and some of them stayed as protoplanets such as Ceres. Now, after some time, especially when a lot of matter started to accumulate in the center, the sun actually became a star. So we're gonna raise its mass until it becomes a protostar. There you go. So now it is a proto-sun. So at this point it started growing larger and larger, but at the same time, because it was now a star, it was actually creating a lot of solar flares and a lot of pressure that moved or pushed out a lot of these particles through the outer solar system, specifically beyond approximately 2 astronomical units, or beyond the orbit of Mars, or where Mars currently is. So a lot of the particles, especially lighter particles like hydrogen, helium, and so on, and you can already kind of see them flying away, they were pushed away from the center and moved to the outer solar system. So it kind of looked like this. So it started to look more like this, and specifically on the outskirts here you had a lot of the lighter materials, things like hydrogen and helium, or even some of the ices like water, methane, and so on and so forth. A lot of it got pushed away from the center of the solar system, and only the heavier, rockier things were in the middle. So things like iron and silicate stayed in the middle, and these actually turned into dwarf planets. And just to simulate what it kind of looked like, so I just added a few random dwarf planets, or actually terrestrial planets, that are now orbiting in the center, with the outskirts being filled with both rocks but also a lot of gases and a lot of ices. And when I say ice, I mean methane, water, and ammonia. Now all of this stuff started orbiting here, and this is where or how the gas giants started to appear. So there's no one theory that explains how gas giants were formed, but today I'm going to show you one of those theories that I kind of like the most, and this is essentially what very likely possibly happened. So as these terrestrial planets in the middle started to kind of orbit each other and collapse into one another and create bigger and bigger planets, one or two, or specifically 4 of them, and I'm talking about the beginning of Neptune, Uranus, Saturn, and Jupiter, possibly moved to the outskirts, or maybe they were created somewhere over here, somewhere farther away from the sun. So some of these stars, or not stars, some of these planets somehow managed to make it to the outer side and essentially started orbiting right here. So here we have 4 different terrestrial planets. So possibly they were either kicked out from the inner solar system, or possibly they were actually made here in the middle. We don't really know exactly how they were formed. but we know what happened afterwards. What happened afterwards is this. And I'm actually going to reset this and change this a little bit so it's a little bit faster and looks a little bit better as well. I'm going to use, instead of a protosun, I'm going to actually use a black hole, and we're going to make a completely new simulation where instead of a sun, we're going to have a very large black hole, approximately 10,000 masses of sun. And here, we're going to pretend that this is the inner solar system, and this is the outer solar system. So we're going to add some material to this black hole. Specifically, we're going to add a lot of rings made out of hydrogen. So this is basically to simulate the gas. It's going to be very massive. In total, this mass of this whole gas is going to be about 3 masses of Jupiter. So kind of like this. So here we go. Here's essentially our simulation of this massive amount of gas that has been now pushed away from the sun. And right in the middle of it, we're going to put a few bodies, few objects. So here, let's go into the simulation again. All right, so here we go. We have a few terrestrial objects in the center. These are actually moon-sized, and a lot of gaseous or gas-like material orbiting around the black hole. So I'm going to unpause the game now, and what you'll see is, look at that, they already started gaining mass. As they essentially flew through this gas, they started to acquire and to essentially just pick up the gas as they were passing through it. Now this is sort of like, imagine if you go outside in the snow, if you ever seen the snow, and you try to, oh, look at that, it's already turned into a gas giant, and you try to basically take a small snowball and you try to roll it on the snow. The snow will accumulate and it will actually get stuck to the snowball, and then eventually it will become larger and larger until it turns into a very large snowball, right? This is essentially how you make snowmen. Now here what's happening is, as these moons basically vacuum up all of this gas on the outskirts, they are essentially growing in size, and we don't really know how many there were in the beginning, if it was more than one, if it was just one. But we know that at the end there was only one terrestrial planet that was approximately 1.5 times the size of Earth, and it accumulated all of this gas and helium and turned into Jupiter. Another one a little bit farther away did the same thing and accumulated all of the gas and turned to Saturn. Now further than Saturn, we had other elements such as ammonia, methane and water, and this is where Uranus and Neptune were formed, and this is where they accumulated their gases, because they don't have as much hydrogen and helium, but they do have some, meaning that in the beginning Uranus and Saturn were possibly even in this region as well. They were actually possibly here first, and then somehow got kicked out into the outer solar system, where they acquired even more material, specifically things like methane, water, and other ices that turned them a little bit different from Jupiter and Saturn. Alright, so we're gonna run this simulation for a few days, few hours, and let's see where this gets us. So right now, they've kind of slowed down in terms of acquiring mass, but this one here is already at about 16% of Jupiter. So this is already almost the size of Jupiter, and what we're going to do is we're just going to wait for them to start interacting with each other to basically acquire more and more mass. And we're also possibly going to simulate the basically sun pushing away more gas and essentially pushing it into these rings, which would obviously cause these terrestrial planets to acquire even more mass and grow in size. So these terrestrial planets, they are now covered in gas, and once they're actually cooled down, they will become gas giants. It will take probably a few years for them to cool down, but you'll see after I'm done with the simulation that they will actually look a lot different. So today we still don't know whether there were several objects like I simulated right here, or whether it was just one object, specifically terrestrial Jupiter, that basically sucked up all of this hydrogen and helium. But it's possible that there were actually many smaller objects that then collided into one another, like you'll see happening here soon. They'll actually start colliding into each other, creating this large gas giant called Jupiter. So we're not really sure what happened and how it happened, but here I think is possibly the first collision. No, they missed each other. They're gonna collide soon, but not yet. Now, if I show you the chart here, you can kind of see that some of them have already acquired gas giant-like properties. So this one right here is just a little bit hot, but it has a mass of 0.617, or it's actually increasing. So 62% mass of Jupiter, and going up as it's sucking in more and more hydrogen and helium. I guess hydrogen in this case, because I didn't add any helium, but I only added hydrogen. And as it's increasing in size, it will come closer and closer to looking like Jupiter. Now, when it cools down, it will be a gas giant. Right now, it's really hot because of all of this collision with various objects, various things that it's basically passing by and smacking into. But you can see the mass here, it's actually going up. So if I show you the graph, you'll notice that the mass is slowly going up. This is math in numbers of Earths. So this is how its mass is increasing as it's essentially flying through this gas of hydrogen that I've created. Now, let's go back to the simulation, and I'm just going to show you what it looks like. So here we go. So, and the reason why they're so hot is because all of this gas is actually colliding into them. It's creating these huge, massive explosions on the surface. And this is really what's happening here and why they're all on fire. And here you can actually see the explosions as they occur as the gas accumulates on the surface. So these explosions are from the chunks of hydrogen colliding with Jupiter. Now, it may not have been like that, but it's quite possible that Jupiter did actually experience a lot of collisions with huge chunks of rock and various gases on those rocks. So it's very possible that it actually did go through this kind of explosion phase where it was actually on fire and really hot. Now here's the chart view again, just to kind of show you that they're still actually growing and they haven't even collided with each other, but their mass is increasing non-stop. So as they're flying through this gaseous cloud, they're acquiring mass and increasing in both size and mass as well. So most of these started as one moon and have now increased to anywhere between 16% of Jupiter mass to 76% of Jupiter mass. And still, we're still not done. There's still quite a lot of materials, quite a lot of gas left. And all of this gas will eventually get sucked in to those gas giants and essentially create all of these gas giants that will orbit around the central sun. Now, there's one thing I forgot to mention, and this is something I should probably mention now. And that is, of course, that these gas giants were also rotating around their own axes, and at the same time they were actually creating their own kind of a field as well. There should be, at least, I'm going to use the biggest one here, there should be another sort of a ring around this gas giant itself. So I'm going to make another one here. So here we go. I kind of tried to simulate this ring around this particular moon. This is moon number 3, the biggest one we have. Now, unfortunately, my rings are flying away because there's a lot of other objects in this area interacting with those rings and stealing my particles, which means that in reality, there were probably no other big bodies flying in the region. It was probably only Jupiter itself and Saturn itself that had basically their own orbit. Now, once these guys are gone, we're going to try this again, but essentially what this started is there were a lot of rings orbiting around Jupiter and Saturn, and some of those rings became their satellites like Titan, Io, Europa, and so on, and some of them became the rings. So for example, both Jupiter and Saturn have rings around them, and this is how they were formed, because early on when the gas giants were still forming, they also had their own little system going on with things orbiting around them. Now, just to accelerate things a little bit, I'm going to erase the rest of the particles because they're kind of slowing down the game right now. And what we're going to do is we're going to observe the collisions of these gas giants. Whether this happened or not, we don't really know, but it's very likely that at least some of the gas giants had some major collisions with each other and possibly created some of the bigger gas giants, like for example Jupiter. So we're going to accelerate this a little bit and just to see the collisions in action. So here we go. It looks like we have our first collision right here. There we go. This is the first massive collision of two gas giants, even though they actually kind of separated from each other. But this guy right here, I think he lost a lot of mass. He's now at 1% of Jupiter size. However, this other guy gained a lot of mass. He is now at 145% of Jupiter. So that's quite a large gas giant we have. Definitely larger than anything in our solar system, but this is possibly how a lot of them were formed in the beginning. And here's another one. So as you can see, it only took a few seconds for another collision to occur. Another massive explosion right here. And these two actually didn't really exchange mass too much, so they didn't really damage each other too much, because they're still relatively similar in size. And that is a really interesting look. I've actually never seen a gas giant look this way. Whoa, okay, that was kind of scary. And looks like this guy just stole a huge amount of mass from my other Jupiter. My other Jupiter is a little bit smaller now. Did not expect it at all, but look at that. This is a kind of a cool look. I've never seen this in a game before. Now, if you look really closely, you can actually see the features of a gas giant already, except that obviously this is a little bit too hot right now. They're going to cool down after a few years, but right now this is essentially a very, very hot gas giant. Now, both of these surprisingly got into orbit around each other, which is something I've never seen before. This was really, really random, but look at how fast this guy is spinning. This is milliseconds per second, and how slow this other guy is spinning. This one is barely spinning at all. And they're actually going to be orbiting each other. So we have our first dual gas giant system, which has been created completely by accident through interaction of these 10 moons that became gas giants. Now let's see what else happens, because now I'm really, really curious what I'm actually going to be able to create here, because all I was planning to do is create a gas giant, but not only did I create something like 10 of them, I am now possibly going to be creating some crazy, awesome dual and possibly even triple systems here. And of course, there had to be someone to destroy all of this balance by colliding with one of my gas giants. So now there's no more dual system, no more binary system, because there was someone else, and so there's another gas giant that just smacked into them. Alright, so that was the end of my binary system. I thought I did something really amazing, but now it's gone. That is a gorgeous effect. Look at this. There's like 4 different gas giants chasing us, and some of them are on fire. Now, I'm actually going to wait for all of them to either collide with each other or turn into fragments, and then we're going to see who the survivor of all of this madness is. And this survivor is going to be our Jupiter. He's going to be crowned, he or she is going to be crowned Jupiter the Final. And I think this will be the end of this video. And here we go, another collision. And what happened? Nothing happened. Oh, okay, oh no, it's losing mass. We lost a little bit of mass here. So all of these collisions make me wonder if maybe, just maybe, when Jupiter was being created, it was actually the only terrestrial object in that particular orbit. It's very possible that there were no other objects that it had to compete with, unlike in the creation of actual terrestrial planets. When dwarf planets do actually collide into each other to create a terrestrial planet. Here, it's very possible that it was just one object. It's one massive object that sort of occupied the space and sucked in all of the hydrogen and helium that was in that particular region. So, as you can see, because all of these collisions are creating so many fragments and so many different unpredictable, oh, this is beautiful, different unpredictable effects, I have a feeling that it's very possible that Jupiter was alone, and so was Saturn, and so was Uranus and Neptune. Now, this is one of the last few collisions. There's only about 4 of these objects left. Most of them turn into fragments, which I've been kind of removing just to save up on CPU speed. And basically, every time they collide, I remove the fragments, remove the particles, and just observe what happens next. As you can see, Jupiter Senior is still at about 177% of mass of Jupiter. And the other objects, the other 3 objects, are still relatively large, but they've been kind of either decreasing in size or combining with each other. So I think at the end there's only going to be one left. It looks like this is, of course, simulating millions of years. Looks like after millions of years, there's still going to be just one major object in this particular orbit. Here comes another collision, and Jupiter Senior is now 183% of Jupiter size. I'm going to erase the fragments and particles again. And we now only have, I believe, 2 objects left. Let's just double check. This one is too tiny. I'm going to erase it just so it doesn't waste my space. This one is actually very large. It's about 103% size of Jupiter. So we only have 3 objects left, and let's see if Jupiter Senior prevails and becomes the main object in this orbit. Here comes Jupiter Senior coming up behind Moon 7, and it is now 2 times the size of Jupiter, and moon number 7 has decreased to about 82%. Now you may actually notice that none of these gas giants are able to push each other into our solar system. So for an object like Saturn to form, it would have to form here from the beginning. None of these guys were able to push each other or to slingshot each other into our solar system or orbit farther away from the sun or from black hole, meaning that or suggesting that it's very likely that other gas giants like Saturn, Neptune, and Uranus may have been formed by themselves somewhere else. Now, there have been suggestions and theories about Uranus and Neptune saying that maybe they were formed in the middle or closer to the sun and then moved to the outer solar system, but we have no idea how it happened because a mass of Jupiter and a mass of Neptune is relatively close together, and they're not very far off from each other, so one of them may not be able to actually successfully push the other one into this outer orbit. And it looks like these last two gas giants are being very resilient. They just don't want to combine with my Jupiter Senior, so I'm going to do this manually. We're actually just going to remove them for now because we don't really need them. And what we're going to do is simulate the final creation of a gas giant, or essentially the rings and the satellites around a gas giant. So we're gonna go into Add, Rings, and look at that, this is our Jupiter Senior in its final form. So there's a few rings, a few moons orbiting around it, and it's a gas giant of about 2.44 masses of Jupiter. So this is essentially what we got at the end, but let's just summarize all of this from scratch. And when I say summarize, I mean let's actually recreate the beginning of solar system when the sun just became a star and started to emit huge amounts of radiation, pushing out all of this gas into our solar system. So in the center here, we had a few rocky planets orbiting around, and these were most likely dwarf planets that collapsed into each other and created Earth, Venus, Mercury, and Mars. Then somewhere here on the outskirts, we had two more possible rocky planets, one of whom became Jupiter by basically sucking up all of this gas that was flying around on the outskirts, and the other one became Saturn by doing just exactly the same but in a slightly different location. Then somewhere here, somewhere a little bit farther away, we had Proto-Uranus and Proto-Neptune. So Uranus and Neptune may have started somewhere closer to the solar system, or they may have actually already been in this region because they're quite massive. It's really hard to budge them so far into our solar system. So we don't really know how exactly it happened, but they eventually ended up on the outskirts here, and what they did is vacuumed up all of the ices, all of the methane, water, and all of the stuff that they're now having on the inside. So unlike Jupiter and Saturn, these guys actually have a slightly different composition. They have mostly methane and water, and of course other stuff like oxygen, carbon, nitrogen, and sulfur. A lot of the heavier materials that were then pushed to the outer solar system by the same solar flares that pushed hydrogen and helium to this particular region. So this is possibly what the proto-solar system looked like. There might have been more things here in between as well. And in the center, there were dwarf planets smacking into each other, creating the terrestrial planets that we have today. Anyway, so hopefully you enjoyed this video, and hopefully now you know how the gas giants were made, and this was clear and interesting. If you enjoyed this video, check out some of the other Universe Sandbox 2 videos I posted in the link that you see on your screen right now. And also post a comment. What do you think? Do you think Uranus and Neptune were formed where they currently are? Do you think they were pushed away? And if so, what pushed them so far? Why are they so far away from Jupiter and Saturn? And what are they doing in the outer solar system? And once again, thank you so much for watching and subscribing and liking the videos. And I'll game you later, guys. Bye-bye.